Hello, hello friends. Today's topic is BJT, Bipolar Junction Transistor. Why it is called bipolar? Because the electrons and holes both are used for the conduction purpose in the transistor. That's why this transistor is known as a bipolar junction transistor. So unipolar junction transistor is also available, but the today topic is BJT. First of all, what is a transistor? So basically transistor is a transfer resistor. So the transfer resistor hence transistor. So in the case of transistors, you have to apply input at low resistance and the output to high resistance. So transistor we use for transfer our signal at the output side. So basis on the transfer plus resistor is equal to transistor. So basically transistor is a semiconductor device used to amplify or switch electronic signals and electric power. So it is composed of semiconductor material usually with at least three terminals for the connections to the external circuit. So these three terminal is known as emitter, base and collector. So basically the transistor is a 2 PN diode back to back connect to it. So basically there are two types of transistor are available. One is NPN, second PNP transistor. So in the case of NPN, P layer is between 2N, and the case of NPN, N layer is between the 2P layer. So what is the difference between the NPN and the PNP transistor is, so when you consider the PNP transistor, so the emitter arrow is inside your transistor. So when arrow is inside your transistor, so this is defined by the PNP transistor by the symbolic representations. And when your arrow is indicate the outside of your emitter terminal from the transistor, so this is a symbol representation of emitter transistor. So basis on this arrow you can define as a PNP or NPN transistor. So third symbol represent over here is the actual diagram. When you purchase a transistor from the market, so it looks like the third one diagram. So the emitter, base and collector, all three terminal will be is equal. So you can define the flat surface in front of you, and the left will the emitter, center with the base, and the last is the collector. So basis on this you can just define the terminal of this transistor by the physical transistor. So now this theory is the two diodes. So when you combine the NPN, so P is a sandwich between the two N layer. So you can define then the two diode anode will be at P side, because P is positive means P terminal. When you apply the positive voltage at the P terminal, so the both side will be N. So P is defined as anode. So anode of this both diode will be connected to base terminal, and the cathode is one for collector and the second cathode of considered as a emitter. In the case of the PNP transistor, N is a sandwich between the two P layer. So at that time we have to apply the two positive polarity at the 2P layer. So the both terminal of cathode will be connected to the base. So at that time one anode represent the cathode and the second anode represent the emitter. I'm just clearly mentioned over here, the diode connecting base to emitter is important. Once here it matches the direction of arrow. I'm just giving the previous slide the arrow indication how to define by the arrow whether it's NPN or PNP transistor, and so you which way the current is intended to flow through the transistor. So based on current you can also define the NP or PNP, or based on the two diode transistors you can just define the whether it is NPN or PNP transistor. Clear? So now the third one is a structure. Transistor structure is basically the three terminal emitter, base and collector. So according to these three terminal, these three region has a different doping level and the different size in the structure. So the collector is the highest in the size, and then after emitter, and then after base. When the consider about the doping scenario, the emitter has a highest doping compared to the collector, and collector has a highest doping compared to the base. According to the base is very thin layer compared to emitter and collector, and is a very lightly doped, clear, compared to emitter and collector. So basis on this, emitter is considered approx equal to the collector for the region wise. According to doping wise, emitter is the highest. So the next thing is a transistor configuration. So I'm just connecting the basic configuration of transistor. So I'm just considering the NPN transistor. So you can just define NPN transistor by arrowing. So arrow is outside, so you can define the transistor is NPN. So the first terminal is emitter, second is base, and third is connector. So when you connect NPN transistor biasing, so at that time first N defined by emitter, the first P defined by the base, and the second N connected to the collector. So the any kind of proper configuration of any transistor, you have to connect two biasing with transistor. So the base is the center, so base represent as a common between emitter and collector. Consider as a emitter, initially you have to consider emitter is common, so at that time base and collector is a input and output, and emitter is common, and you consider common as a collector, so at that time emitter and base is considered as the input and output. So using the 3-point type of configuration is there. So according to the configuration is there, we have connected with the emitter as common terminal, we have to apply input at the base part and the output at the collector part. So we have to apply one supply voltage known as a forward supply. So this is considered as a plus terminal, this considered as a minus terminal. So when you apply plus to P part and minus to N part, so this is a one diode. P is applied to positive terminal and N is applied to minus terminal. So this junction is a forward bias junction. So the VBE supply is used for the forward bias junction J1. Clear? The second supply is known as a, why it is called VBE? Because it is applied between emitter and base, that's why it's known as VBE. Clear? The second supply is VCB. Why it is called VCB? Because it is applied between the collector and the base terminal, and the minus sign represent over here and the plus side represent over here. So when you apply plus to N terminal and minus to P terminal, so definitely this junction is known as a reverse bias junction. So any proper configuration of transistor, one junction is in the input junction is compulsory into the forward bias, and the output junction compulsory into the reverse bias. So we have to apply VBE for the case forward bias, and we have to apply VCB for the reverse bias. So this is a basic configuration of transistor. So when you apply any kind of input is there, so this is known as IE current. So this current is known as a emitter current. It will pass into the base region because emitter is highly doped. So majority carrier is there in the emitter side, and the base is very lightly doped. So carrier is concentration is very low. So some of concentrations, some of emitter current will recombination over here, because in case of N layer has a majority as a electron. In the case of P, base layer is known as a P. So P is a majority as a whole. So this majority will convert in this base region and consider as a recombination. So rest of current will be passed to the IC. So basis on this current scenario, one equation is created is equal. The emitter current is always equal to base current plus collector current. So in this case, collector current plus base current is equal to input emitter current. So basis on this transistor configuration, you can just easily understand what is I is known as a emitter current, what is IB is known as a base current, and what is IC, so IC is known as a collector current. When input current is IE is represented through base region through collector, when it passes through base region, some recombination chances is there, and the rest of current will pass to the collector. I'm just clearly discussing the previous slide, base is very lightly doped, so recombination chances in the base is hardly 5%. So when you consider the 100% current flow from emitter to collector, so 5% recombination is represent in the base region. So 100 minus 5%, 95% current emitter current will reach at the collector side. So 95% plus 5% is equal to 100%. So basis on this equation, I is equal to IB plus IC. So I hope you can clearly understand. So I'm just removing this. The next slide is working of transistor. So this is a working based on the current scenario. So the red arrow indicates the maximum current flow from emitter through base to the collector. But in the case of P region in the base side, one holes is there. So in this case, you can consider that this is a recombination part represent over here. So maximum current will flow emitter to the collector side. So this is known as IE The recombination part generated is base is IB and the collector side is IC. So IE is equal to IB plus IC. So this is a normal working scenario of any basic transistor for the biasing operation. Clear? So basis on this supply voltage, first of all, I'm just considering the one supply voltage here. So this is a forward bias. So input junction J1 is always forward bias. Output junction J2 is always reverse bias. So basis on this J1 and J2, transistor region will be defined. I'm just repeating, basis on junction J1 and J2, region of transistor will be defined. So when you change this forward bias at input side and reverse bias at output side, your junction will be changed. Your junction will be changed means junction means forward bias or reverse bias will be changed. So according to this junction or your region of transistor will be changed. So consider about the first, when you replace forward bias to reverse bias, so at that time both in the reverse bias. So both in the reverse bias means J1 and J2 both are in the reverse bias. So both junction in reverse bias, there is no current flow because in the reverse bias case there is no any diode is in the conduction medium. So at that time output is equal to 0. Clear? So this is known as a cutoff. This region is known as a cutoff region because there is no any kind of output current and voltage will be generated from the transistor. So in the second case, when you apply one junction is forward bias and second junction is reverse bias, the same condition given is over here. So consider as a J1 is a forward bias and J2 is a reverse bias. So at that time, this first junction is a forward bias, it will flow the electron, and the second junction is reverse bias, so it will oppose, and according to the reverse bias voltage you can generate your output voltage. So basis on the second condition, one junction is forward bias, second junction is reverse bias. So this is known as a amplification region because using this voltage you can create a depletion level over here because this is a reverse bias. So basis on this you can amplify the signal according to your level. So you can decrease or increase any kind of signal using this layer. So input junction is forward bias, output junction is reverse bias. So this is known as a active region. Clear? So now third one, in the case of third, we have to apply forward bias over here. So this is condition over here. So we have converted the reverse bias into the forward bias. So we have to apply first plus voltage over here and minus voltage over here. So both junction in the forward bias. So consider as a J1 is a forward bias junction and the J2 is also the forward bias junction. So both are forward bias junction. So there is no any control in the output side because you can always control to the reverse bias because you can increase the reverse bias voltage, your depletion layer increase, you can decrease the reverse bias voltage, depletion layer width is also decreased. So basis was on that, using J2 you can reverse bias. So amplification purpose J2 is reverse bias. But when you convert J1 and J2 both in the forward bias, so there in the case of forward bias it's look like is open switch. So there is no any control, maximum current will be flow. So maximum will be flow means this is known as a saturation region. So both is forward bias, the region is known as a saturation region. So in the basis on these three supply voltage, we have defined the transistor operating region. So we have considered as a both reverse bias junction. So in the case of both reverse bias junction, so the region is known as a cutoff region. So when we have to convert first region in the forward bias and second region in the reverse bias, the region is known as a active region. In the case of third is FF, in the case first junction is forward bias and the second junction is also forward bias. So both is forward bias, so maximum current is flow. The region is known as a saturation region. So in the upcoming lecture I will discuss in the three different configurations of three different bias. So common base, common collector and the common emitter. So thank you to all of you. So any question regarding this, you can just post any comment over here. I will reply very soon. Thank you.